this time I'm gonna interview Mr. Wojtek Kozaczynski, right?
Yes.
From?
Seattle, USA.
And you work at?
Developer Division, Microsoft Corporation.
Okay, so I asked about that because you're dealing with, I think, Azure technology, right, and telemetry especially. So can you please tell us a little bit about the technical side of telemetry?
Technical side. Yeah. That's an interesting question. Technical side, it's a lot of storage, a lot of queuing technology, a lot of different data processing engines, some of them open source like Elasticsearch, some of them proprietary. It's a microservice architecture. In other words, there's so many different ways that you need to process the data that you cannot build just one solution for it, right? So what you do, it's like looks like sort of like this, that we receive data, and some of the data we just immediately push to some of those near real-time streams, and we don't quite care what they do with it, right? Just we need to reliably send that to those, and they just do some near real-time computation, and there's like 4 or 5 or 6 of them. They do different things, like anomaly detection, that sort of stuff. And the other path, which we call latent compute, that we start writing that data as fast as we can to storage, a lot of storage, and transform and then group it, and there's a next set of consumer subscribers, and those guys just, chew through all that data. And then there is a backend, which is the data access layer, and there's 2 kinds. One is the one that we provide. So we have interfaces that go kind of split to the real time for the immediate data, and go to the batch compute for the data after some duration. So if you, for example, ask for data from now, from 30 minutes back to now, you get the last 5 minutes from the near real time, and you get the 25 minutes from the storage and compute, right? So the backend, which is the query, and what we show to the users is also a combination. It has to understand, parse the query, figure out which is near real time, which is stored, and just sort of aggregate the data. It's a lot of services, a lot of servers, it's kind of scrambled, put it this way.
Okay, and of course, all that traffic is encrypted in some way.
No. When it comes to us, it could be sent over encrypted secure connection. It's up to the sender. When it hits us, we obviously we don't encrypt that. Because we own that data. We have to make sure that the users don't have access to some other people's data, but we don't do encryption. Well, that's not true. It's what's called private sensitive data. We do not decrypt. But basic data, we don't encrypt. We compress, but we don't encrypt.
During transmission?
It's not up to us. It looks like this. We expose an endpoint, and the data comes at us, right? It's an HTTP address, or HTTPS. It's up to the sender, who is the application, to figure out whether they want to go over a secure or not secure connection. That's up to them. We don't, from the application point of view, we don't know how that data is produced in an application. You subscribe to us, we give you an account, and then you say, oh, we give you what's called I key, which is called the instrumentation key, which is an identifier. We don't know what it represents. Most often it represents an application. And then you start sending data, and you stamp that data with this I key, which means I want to look at that data together, right? And so, whoops. So that that could be an application. It could be a component of an application, right? But we don't know what it represents, right? We process it in a particular way. So we hope that when we show it to you, you will make a connection between what you send to us and what you see. But we have no semantic understanding of audio data. All we have is those different processing patterns, right? If you tell us that you want us to watch that metric and fire an alert if something goes up and down, we'll do it. But you have no idea what it means. To us, it's like if it's called CPU, and if I could look at it, I could probably guess that it's a CPU. But I don't know, right? So we need to understand what kind of processing patterns you apply to it, right? But other than that, we have no semantic meaning. Other than we understand that metrics are processed differently and trace messages, which is strings, we parse differently. Like, for example, if you send us a message which is textual information, we parse it, we tokenize it, we index that. So if you ask, how many messages did you see a word which was called foo, which may be a name of a function, we'll tell you, oh yeah, from time so to time so, there are 5,000 messages, there was the word foo in, right? And then you ask us, okay, find all the messages that there was foo in number 55, because maybe foo meant some function and 55 means the response time, right? You know that. So in other words, depending on the type of data, we process that differently because we expect different queries. But it's up to you to figure out what the data means, if it makes any sense.
Okay, quite recently, the word or term telemetry has rather wrong connections. I would say that since the introduction of Windows 10, there were many claims about telemetry introduced, or maybe rather improved in Windows. And now, because so many people are looking for it, trying to dig.
Telemetry about Windows?
Yeah, telemetry of Windows.
Windows itself.
Yeah, Windows itself. Because so many people are trying to dig through those communication, I'd say, channels between Windows and Microsoft, and they see a number of encrypted connections.
Because Windows talks to us. Well, I didn't say that but it's obvious that one of the biggest telemetry services that we have inside Microsoft collect data from Windows and Xboxes. Xbox is one of those. I didn't make that comment either. Xbox started a lot of initial development on telemetry services, right? Xbox, in particular, for shared games that players play against each other around the server, collects a crap of data, an incredible amount of data. Now, Windows itself reports a lot about Windows. I can't remember numbers, but I think we were talking about like 8 million, messages per second coming, because we have to understand the health of Windows. We don't understand what you do, right? I mean, we, for example, see that you run an application, but we have to react to problems with Windows to release patches. So yes, Windows itself, and Windows 10 probably more than other Windows. But the reason is that people finally understand that understanding what's going on there is so critical, right? So yes, Windows is instrumented. I was saying WMI and WinRM and ETW, all this in Windows. Those are the layers, management layers I worked on in Windows that sent a lot of data to Microsoft. But it's not evil. It's just really the main purpose of that is to increase the quality of Windows itself. It's not to spy on people. I mean, that's not the reason.
Yes, that's I would say one of the most frequently repeated sentences that Microsoft collects data just to spy people or just to analyze,
well,
maybe.
I think that it's possible to analyze some of that data to the marketing advantage, right? And I bet you it's probably done, but it's not the main purpose. The main purpose is quality of Windows itself. And Windows 10 has been, you have to see it from the inside, which is, Windows 10 is the first Windows that has been unified. Before Windows 10, we had like Xbox was different Windows, for point of sale was different Windows, for server was different Windows, for laptop was different Windows, for the phone was different Windows. We had like, I don't know how many versions of Windows. Windows 10 is the first version that's the same Windows for all of those. So not surprisingly, if all these guys like Xboxes connected something and phones connected something, somehow it got to be unified. Actually, I am a member of this across Microsoft group that we standardize what kind of telemetry comes, like both from applications and it's called Common Telemetry Schema. And we discuss that and we agree on what the telemetry looks like. So I know all of this stuff, yes. I mean, but once again, it's the purpose is to make Windows better and better. That's the only purpose. And I think legally it cannot be any other purpose.
Right.
Still the evil empire. Is there. Yeah, I know. I work for the evil empires.
Okay, but coming back to those numbers, right? From the perspective of a single user, does it really count? You know.
Well, if I were a user of Windows, right? My question would be, how much do I pay for you guys sending the telemetry? You know, how much of the processing power of the box that I have is going to that crap that you guys send to us, right? Because you're paying for it, right? I mean, you're paying that in the battery, paying in the slowness of your application, that sort of stuff. The rule of thumb is that telemetry should not take more than 3% of the resources, and it takes probably about 1%, right? So that's one concern that I hear. So my answer is probably no more than 1-2% of that you're paying. I don't know if there's any other concern.
Okay, well, that's what I wanted.
There's a measurable number. Yeah. How much data we send about different parts of Windows, as long as the user does not pay additional cost for that, right? Because if we start sending data and all of a sudden we take in 30% of the CPU of your, let's say, laptop, I mean, that would be completely unacceptable. But it's 1-2%, right? So how much data we squeeze into those 2% is up to us, but we will never cross that threshold, right? Now, we can, then we send, but it's mainly about Windows itself, right? It's like, it's kernel level stuff. We're figuring out how we use memory, how we use processes, threading, and all this other stuff, right?
And what about apps, especially from the Windows Store?
Well, apps from Windows Store, most of them are not ours. I don't think there are a few that are ours, like, Skype. I mean, as I said in the presentation, Skype sends a lot of data to Skype because it has to understand. It's like, once again, the purpose is to understand how Skype works, does all those connections, as well as Skype works on devices, right? But most of applications that are in the store, like I download from, I don't know, Expedia or Facebook or that sort of stuff. What telemetry they put into it, we don't know. However, to all the store users, we say, hey, if you build in an application, you put it in the store, don't invent your own telemetry solution. Just, pump the data to us. We'll do that for you cheaper than anybody else. But we don't know. So I don't think we even could legally try to check if they. What we have to make sure, though, is that that particular application cannot collect data about other applications that belong to some other users, and I cannot spy on other ones. I don't know how that's protected. Don't know.
But there is some kind of protection. There is some kind of verification.
Well, use Sandbox. I mean, that's Windows. I mean, you as a user, right? I mean, if device is a single user application, so but still can actually. I don't know if on phones, for example, you can run two applications. I think they, like in Windows Phone, the application gets suspended, right? So they never run at the same time, although they can see each other's resources potentially. It's a little bit outside of my space. I don't know how they can, if then. But going back to my main point, if we cannot verify what applications the store in the store do.
Okay, so well, my point was whether Microsoft, as Microsoft, can see what the others are just transmitting, just to do their own analysis, right? So is by any chance is it possible by any chance that because it goes through your resources, you can use the data for your analysis too, right?
I think there's more than one question in it. Could we see what data applications send? Well, we could, because we own the full stack, right? Do we? No, I think we cannot. Now, can we collect telemetry about your application? Yes, we can, from the outside, right? We, for example, can figure out how much you use of CPU, how much memory you use. As a matter of fact, it's an interesting kind of a paradox, which is if you run an application, let's say for a phone, and you would like to know how much storage you're using and how much CPU you're using, you have to ask Windows, because you don't see yourself, right? You can. So actually, that's the benefit of our SDKs, because our SDKs know how to ask Windows, because you want to know about the environment of your application. So it's kind of a two-way story, right? But yes, but I don't think we collect information about applications as such. We could, because when we launch the applications, at least we know their ID and that sort of stuff. But I don't think if we do. I don't think we do.
Okay, and maybe last but not least, it's everything you say is about telemetry of Windows and applications running on Windows, basically. Plus the cloud, right?
I didn't say that.
Okay.
No, I didn't. As a matter of fact, if you look at set of our SDKs, there are SDKs for Android, iOS, Node.js, Java, and they can run in, I don't know, like we run Node.js in Docker containers, and they can run wherever, right? They can run in Linux, they can run in Windows. The applications can run wherever. Our telemetry service is actually runs in Windows, because that's our platform, right? Azure platform. So that's an interesting thing. Azure Cloud, the hosts in the cloud are Windows. I mean, and Azure infrastructure is Windows. Now, if you ask us for a virtual machine, we'll be equally happy to create you a Linux machine as well as a Windows machine, right? But it so happens that in Azure, I think 75% of all the VMs are actually Windows VMs. If you look at Amazon Cloud, the host operating system is Linux, but you can ask for Windows machines, or you can ask for Linux machines. For their proportion is reversed, right? It's like 75% of all the VMs running in AWS is Linux, and 30% of Windows, right? But we make no assumptions in terms of telemetry As a matter of fact, we make even fewer assumptions. If you send a document, this data document to us, if it's a well-formed document and have a legal I key, so in other words, like it's like, okay, a document here to us came here, it's an event, it has an I key. We look at this I key, say it's a legal I key, it belongs to a tenant. We don't know where it came from. If you can, by hand stitch together a JSON document sent to us, we'll be happy to actually, as a matter of fact, a lot of our ad hoc telemetry, like when we're deploying, right, because we're also watching every deployment, this is a piece of PowerShell script that just stitches together a JSON document. We don't care. If you can hit our endpoint with a well-formed data, we don't care. The point I was making is that people wouldn't do it, right? People want an SDK, right? An SDK is smart enough to collect data it will be very difficult for you to collect, especially about the environment, operating system, user, location, and all this other stuff, right? But I made no assumptions that they run on Windows.
Well, yeah, okay. My intention was that everything that you described is rather software running on some hardware, of course, right? Yeah. But what about networking devices?
Well, that's another aspect which I kind of intentionally omitted, which is the biggest producer of the telemetry data, which has its own telemetry solution, is Azure infrastructure itself. If I remember the number, the estimated network was 300 million events per second. Network. I mean, it's the network guys, the Azure guys, because we work with Azure guys. We share a lot of a lot of technologies with the Azure guys with their projects. So on the scale that I was showing, they are the giga scale. I mean, they are off the chart, right? Because Azure is sending information about all the entire infrastructure. So if you send that even from the one data center about networking, you get unbelievable amount of data, right? So, but I will intentionally, because that's not really a cloud application, that's a cloud infrastructure. Yeah, that's one of the most. And by the way, if you have an Azure account, right, then you get that for some of the information that you get for free. That's exposed to you as a account owner.
Right. So if there was let's say a hypothetical information system that was to be monitored, is there any kind of an asset or type of data source that cannot be connected with Azure telemetry, or maybe that will not cooperate properly?
It would have to be disconnected from the internet. Because if you're on the internet, we're just an HTTP address. That's about it. That's the only requirement. If you completely disconnect it, then. By the way, I mean, an exercise for a student would be to take one of our SDKs, because it's an open source, right? Go to GitHub, clone that, find what that HTTP address is, just find it in the code, change it to your address, write a little, web service, I don't know, take Node.js, write it in 2 days, and create your own little telemetry application. It's an exercise that if I were to teach something, I would just ask the students to do that, right? Create your own one. You can do that, right? But my point is that as long as that something that sends data sits on the internet and sees that HTTP address, right? Then it's not disconnected. If it's completely disconnected, then bets off.
So I think that would be it. Thank you for a conversation.